This lesson is about arithmetic sequences and series. Number one, the first three terms of an arithmetic sequence are as follows: 12, 5, and negative 2. This is an arithmetic sequence because all the numbers differ by negative 7. 5 minus 12 is negative 7, negative 2 minus 5 is negative 7. So the actual definition of an arithmetic sequence is a list of numbers with a definite pattern. If you take any number in the sequence, then subtract it by the previous one, the result is a constant. And so our constant here was negative 7. Each and every time we take a number in the sequence, subtract it from the previous number, we get a constant term of negative 7. So doing the next two terms in the sequence, the last one was negative 2, so we got to subtract 7 from it, negative 9. Subtract 7 from negative 9, it takes you to negative 16. So the next two numbers in the sequence are negative 9 and negative 16. All right, number two. Number two says, suppose that a sequence is defined as follows. A of 1 is negative 2. A of n equals 3 times a of n minus 1 plus 2 for n greater than or equal to 2 for the first four terms of the sequence. All right, so the first term of the sequence they gave us was negative 2. The next term of the sequence would be 3 times a of n minus 1. So for a of 2, put a 2 in here. 2 minus 1 makes that a of 1. So 3 times what a of 1 was, which was negative 2. And then add 2 to it, and you get negative 4. So a quicker definition here for you. Whenever you see n minus 1, it means the previous term. So our previous term here is what we started with. The first term is negative 2. So we put negative 2 in there, times 3, and then add 2. So now that we have this new number, negative 4, it becomes the next, to get the next one, this is the previous term. So you take 3 now, times the negative 4, and add 2 for a of 3. Because when you put the 3 in, it's 3 minus 1, 2, so you're doing a of 2. All right, so going up to the top here, thinking about the whole thing from the top, because this is called a recursive formula, and it's very upsetting for a lot of people. So looking at that list we started with the top, we had 12, 5, negative 2. So coming down here, 12, 5, negative 2, then we had negative 7, negative 16. So a of 1 is 12, a of 2, or the second one on the list is 5, a of 3, a of 4, a of 5. So the fifth one on the sequence is 16, negative 16. The first number in the sequence is 12. So yeah, recursive formula. First one's negative 2, so you take that number, 3 times negative 2, add 2 to get to the next one, and then you put the negative 4 in. 3 times negative 4 plus 2, and you get negative 10. Then take the negative 10 times 3 plus 2, and you get to negative 28. Okay, then the explicit formula, which we'll use sometimes, I wrote it down here, is a of n equals a of 1 plus n minus 1 times d, and a of n is the nth term in the sequence, a of 1 is the first term in the sequence, and d is the common difference between the terms. We'll need to come back to that. Okay, so on the next one it says, for each sequence, determine whether it appears to be an arithmetic if it does not find the common difference. Ignore that for now. We're going to come back to that for number 6. We're on number 3 right now. So all of these have a common difference of 3, which made it an arithmetic with a common difference of 3. This list, 2, 4, 8, 16, sometimes people get upset. They're like, that's arithmetic. It's got a pattern. Yes, but it doesn't have a constant pattern. It went 2, 4, 8. So each and every time, what happened was they multiplied by the number 2. So it was 2 times 2 times 2 more times 2 more. That makes it actually a geometric sequence. So that's not arithmetic. There wasn't a constant number. Like up here, it was 3 every time. That was arithmetic, a constant difference of 3. The next one, 1, negative 4, negative 9, negative 14. That had a constant difference of negative 5. So that's arithmetic. So negative 5 is the common difference. Number 4. Find the 62nd term of the following arithmetic sequence. Again, I'm going to use that explicit formula. A of n equals a of 1 plus n minus 1 times d. So we want to find the 62nd term, so a of 62. So it equals a of 1, which again is the first term in the sequence, 14, plus n minus 1. N is the term we're trying to find, which is 62. So 62 minus 1 is 61. And then times the common difference, which was 6. When you subtract the previous term from the first term, you get 6 every single time. Do the math, you get 380. Notice I highlighted that so that you could know that it's important for you to know. And on the first page, I had some things highlighted. This is a recursive formula. N of n minus 1 means the previous term. A of n is equal to a of 1 plus parentheses n minus 1 times d. A of n is the nth term of the sequence. A of 1 is the first term of the sequence. And d equals common difference between the terms. Number 5. Number 5 says find the 13th term of the arithmetic sequence whose common difference is 6. The first term is a of 1 equals 1. So again, a of n, so we're doing a of 13 equals a of 1, which is the first term in the sequence, which was 1, and then plus, let's see, n minus 1 times d. So n's what term we're trying to find, which is the 13th term. So 13 minus 1 times the common difference, which was 6. They gave it to us right here, d is 6. Do the math, you get 73. Number 6, for the arithmetic sequence, the 7th term a of 7 is equal to negative 71, and the 40th term a of 40 is equal to negative 302. All right, so setting them up here, we have the first one, negative 71, or a of n, the term is negative 71, equals a of 1, we don't know what a of 1 is on the list, they didn't tell us, plus, now they said it's a 7th term, so 7 minus 1, and then times a common difference, we don't know what that is, so that gives us one equation. So our other equation here, they told us another term is negative 302, and it was the 84th term. No, we want to find the 84th term. It's the 40th term. All right, so negative 302 equals a of 1 plus, it's the 40th term for negative 302, so 40 minus 1, then times the common difference. All right, so that makes the number 6, and that makes number 39, so we're going to go to the top now. So I've got two equations with two unknowns, so we have a system of equations to solve. So going up to the top, here's our system. Negative 71 equals a of 1 plus 6d, and negative 302 equals a of 1 plus 39d. So remember, to solve a system of equations, you can do addition, subtraction, substitution. You could graph and find the intersection of them to see what the x, y are. Here it's a1 and d. It's the same thing as x and y we're trying to find. I did subtraction. So subtracting it, negative 71 minus negative 302 is 231. A of 1 minus a of 1, gone. 6 minus 39 is negative 33. Divide, and it makes d is equal to negative 7. So then therefore, the 3 dots in a triangle shape means therefore. So therefore, plugging it in, remember once you find one letter, you have to go back to find the other letter still. So I plugged it into the first equation. You can plug it into either one. I just went for the first one. So plugging the d into the first one, plugging that d in there, negative 71 equals a of 1, which we don't know, plus 6 times d, and d is negative 7. So cleaning that up, I get a of 1 is negative 29. Wow, you'd think we're done, but we're not. They want to know what the 84th term is. So now we got to keep going. What is the 84th term? Well, that would equal a of 1 plus n minus 1 times d. It's the 84th term, so 84 minus 1. We got d, we got a of 1. Do the math, you get negative 610. All right, number 7. Number 7 says, an arithmetic sequence is given below. Write an explicit formula for the nth term a of n. So again, a of n is equal to a of 1 plus n minus 1 times d. We know the first term, a of 1, is 14. The common difference is 7. So plug in the 7, plug in the 14. I'm going to distribute the 7, so that makes 7n minus 7. Clean it up. 7 plus 7n, and I rearranged it so that it's in standard form, so it looks pretty. In standard form, you have the descending order of powers for the letters, so n goes first, so 7n plus 7. Again, it just makes it look pretty, kind of like capitalizing a sentence and putting it at the end, period at the end of the sentence. When you write math, you write it a certain way to make it look nice. This isn't wrong, but this is prettier. Number 8. Write a recursive formula for the following arithmetic sequence. All right, So recursive, and we talked about that back on the first page. They gave us a recursive formula here. A of 1 was equal to negative 2, and then the next term in the sequence is 3 times a of n minus 1 plus 2 for n greater than or equal to 2. Notice we got for n greater than or equal to 2, we got a of 1, we got a of n. All right, so I highlighted for you what is going to stay the same each and every time. So each and every time you're going to write down what the first term of the sequence is. So the highlighted part, a of 1, and then put in what the first term is, which is negative 6 on this problem. And then you write a of n equals a of n minus 1, which means the previous term. And then you put down the common difference. And then here our common difference was negative 2. So for the next term in the sequence, which would be 2 or greater, this equation holds true, which is why we have to write n greater than or equal to 2. You could also write for n greater than 1. And if you're going into overachievement, you could write where n's an integer. Number 9, compute the sums below. Assume that the terms in the first sum are consecutive terms of an arithmetic sequence. All right, so the sum, I wrote it down here for you. The sum of an arithmetic sequence S of n is equal to n divided by 2 times a of 1 plus a of n, where n here is equal to the last number in the sequence. So the last number in this sequence is 229. The first number is 7. The problem is we don't know what n is. What number in the sequence is it? This one's 1, a of 1, a of 2, a of 3. This is a of what? We don't know. So we're going to have to plug it in. So a of n is 229. The common difference on this one is 2. The first term in the list was 7. So you clean it up and solve for it. Distribute the 2, so that would give you 2n minus 2. You get n is 112. Knowing n is 112, S of n, or the sum of the first 112 numbers in the list, is equal to n divided by 2. So n is 112, S of n, 112 divided by 2. First term in the list, 7. Last term in the list, 229. Do the math, you get 13,216. And the next one, sigma means sum. We want to find the sum from k equal to 1 to 129 for this expression, negative 4k plus 13. So when k is equal to 1, if I plug the number 1 in up here, you'd have negative 4 times 1 plus 13. So that would give you 9. If k was equal to 129, which is the last term in the sequence, you'd have negative 4 times k, 129, plus 13, and that gives you negative 503. So the sum of all 129 numbers in this expression, or for the sequence from 1 to 129, is 129 divided by 2. The first number in the sequence is 9. The last number in the sequence was negative 503, which gives you negative 31,863. All right, so let me know if you need some more help with it. We'll have some Zoom time together. Have a good night.